Welcome to the first of a series of videos on quadratics. In part 1 we're just going to look at the very basic quadratic, which is of the form x squared plus bx plus c. So b and c are numbers and the coefficient of x squared is 1. That is, the number in front of x squared would just be 1. Okay, so what we have on the left here is a pair of brackets. In other words, something that's already been factorized. You've got one bracket multiplied by another, fully factorized. And we're going to convert it into the form x squared plus bx plus c. Now the answers are here on the right, but I want you to see how you can get to them using this well-known mnemonic FOIL, standing for first, outer, inner, last. Okay, and it quite literally means that you take the terms in that order and combine them. So we have x times x is the first term in each bracket, which is x squared. Okay, then we have the outer term, which is x times 3, which is 3x. Then we take the inner terms, which are 5 and x, to get plus 5x. And finally, the last term in each bracket, which is the 5 times the 3, which is the 15. And hopefully you can see now that the middle two terms there, the 3x and the 5x, combine to give us the 8x that we see in the middle there. All right, normally you would go straight from there to there and combine those two terms together. But that is the process of expanding brackets. Okay, we could do the same for this one, and you could see if you apply the first term here, would be x times x, which would be x squared again. The outer term would be x times 1, which is 1x, or just x. The inner term would be minus 3x, and the last terms would give us minus 3, okay, because it's minus 1 times 3. And when you combine those two middle terms there, again you can see that you get x minus 3x is minus 2x. Okay, the same kind of procedure has been applied to here and here to get to these. Okay, now there's a couple of special cases I want to consider with you now. First of all, if you have x plus 3 squared, or x plus 3 all squared, as we tend to say, it does not mean that you square the x and you square the 3 to give you x squared plus 9. That is wrong. Okay, what you need to do is recognize that that in fact is the same as x plus 3 times itself. In other words, it's this. Okay, and I would encourage you to write it as a product of two brackets like that, and then you can apply FOIL to it in the usual way, and that would give you x squared plus 6x plus 9 as the correct expansion of that bracket. Okay, that is called a perfect square because it's a single entity that has been squared. Okay, a perfect square. Now this is the other special case, and this is when you have x minus a number multiplied by x plus the same number. Okay, and what happens here when you do expand it out using FOIL is you get your first term is x squared, as you would expect. Now your outer term is plus 2x, and your inner term is minus 2x. Okay, and your last term is minus 2 times 2, which is minus 4. Okay, and you'll notice the result, which I've already got here for you. The x term the bx term in the middle disappears. And that is quite easy to see why, because you have a plus 2x and a minus 2x that cancel out and give you 0. So there's a 0x in the middle of that. Okay, so that is called the difference of two squares. Okay, so when you have a bracket like this with a minus and the same bracket but with a plus, it's called the difference of two squares. And the reason it's called that is because, look, we have x squared, that's one number, a square number. We have 4, which is also a square number because it comes from 2 times 2. And we have a minus between them, which is why we use the word difference. So it's the difference of two squares, and that's what it looks like in factorized form. Okay, so we're moving on now to this concept of factorizing. Now, this is where you're given a quadratic in this form, and you've got to factorize it into a pair of brackets that are multiplied together. Now, not all quadratic expressions will factorize, but you wouldn't be asked to factorize one unless it was possible. So what I'm going to do now is move away the stuff from the left here that we've done. Let's take that out, and what we're going to do is concentrate on the original expressions there without the brackets. Okay, so we're concentrating on the expressions that we're going to factorize, which are showing on the screen now. Okay, I'm just going to take these back across here. So you now can imagine that you were given these expressions and asked to factorize them. So the first thing I'm going to do is I'm going to look at this. Notice that the term in front of x squared is always 1 at the moment. We're going to go on to when it's not 1 in a later video. Okay, so we're going to look for factors of this number that add together to give this number. All right, so I'm going to say, right, this is going to be factorized, so it's going to go into a pair of brackets like this. Okay, and then the factors of 15 that add to give me 8 are 5 and 3. And because they're both plus signs here, we can be confident that, well, 5 times 3 is 15 and 5 plus 3 is 8. That is the full factorization of that quadratic expression there. All right. Now the next one, we're looking for factors of -3 that add together to give -2. Now one of these is going to be a minus and one's going to be a plus, because the only way of getting a negative number by multiplying two numbers together is that one's negative and the other is positive. So we can be confident that one's a minus and one's a plus. Now, it's either going to be +3 times -1, or it's going to be -3 times +1. Well, in order to add up to -2, we'll need -3 and +1. Okay? Because when we multiply those together, we get -3, and when we add -3 and 1 together, we get -2. Okay, in the third one here, we are going to look for factors of 3 that add up to -4. Now, in this case, they both must be negative. Okay, and the reason for that is that two negatives multiplied together make a positive. But also, because this is negative, in order to make -4, it's got to come from two negative numbers added together, or certainly one of them has to be negative. So what we're going to do now is say, right, what pair of numbers multiply to give 3 and add to give -4? And hopefully we can see that it's going to be -3 and -1. All right? And you can easily check this by doing FOIL on this to see if you get back to this. Okay, and the final one I've got here in this group is that I'm looking for factors of -6 that add to give me 5. Now again, one must be a minus and one must be a plus. Okay, because to make -6, it's got to come from a negative number times a positive number. All right, so it's just a question of thinking of the factors of 6. Well, it could either be 1 and 6 or 2 and 3, and then deciding which pair will give me the 5, and which one's the negative and which one's the positive. Now, you could be fooled by this one actually, because a lot of people would think of 3 and 2 straight away because of the 5, but actually one's a minus and one's a plus. So to get the +5, you actually need +6 and -1. Okay, because 6 times -1 is -6, and 6 plus -1 is 5. Okay, so that's a factorization process that's been applied to these 4 quadratic expressions. Now this one, you can do the same thing, but then hopefully recognize that it leads you to the perfect square. So let's see what happens here. Well, the factors of 9 that add up to 6 are clearly going to be 3 and 3. Okay, so we could write it straight away as that, x plus 3 times x plus 3. But we would be expected at that point to recognize that that's a perfect square, which is actually the same as x plus 3 all squared, like that. And this final one is, you might be thinking, well, how do we see what we are adding the 2 factors to be? We're looking for factors of -4, but they've got to add up to what? Well, they've got to add up to 0, because you could think of this as being x squared minus 0x minus 4, or x squared plus 0x plus 4. It doesn't really matter if you didn't recognize it as the difference of 2 squares. So you could say that is exactly the same as this. So now I'm looking for the factors of -4 that add up to 0. Well, they would have to be 2 and -2, wouldn't they? So I write that as x plus 2 times x minus 2. Okay? But most times you would recognize that as the difference of 2 squares, and you wouldn't need to write this extra step in. Okay, so that's an introduction to the special cases and cases where the x squared coefficient is 1. I just want to show you one more thing. This quadratic expression could be written in many different ways. Let's just take the first one. It could, for example, be written as x brackets x plus 8, okay, plus 15, okay. There are other ways you could rearrange it. It could be written as the same one here, could be written as simple as something like 15 plus 8x plus x squared. So it's not necessarily arranged in the way that you might expect it to be, and sometimes you need to take the initiative and rearrange it and recognize that you're dealing with a quadratic expression. Okay, and a quadratic expression is one where the highest power of x is x squared. It may contain an x term, it may contain a number as well, but it must contain an x squared term. Okay, that's the end of this introductory video. Next we'll move on to quadratics where the number in front of x squared is other than 1.